In the previous videos in this unit, we've looked at various forms of loops. The for loop, which is the most common, and the while loop, which we use when we don't need to update or initialize a loop variable. All of these loops are based on the idea of a continuing condition, a Boolean condition which is used to decide if the next iteration of the loop will be executed. There are also two other commands, break and continue, which can be used within loops. These commands are dangerous, not because they'll make your code inherently bad, but because they can easily be misused. The important part of this video isn't how to use these commands, it's why you might. Here's an example from the last video. The code in the loop body asks the user for an integer. It adds the integer that is received to the total, and then stops when the integer received is a 0. What if we wanted to change this code so that the loop stops immediately when the integer is negative? Here's a simple fix. We'll just change the condition. We want it to stop when the current integer is less than or equal to 0, so we have the loop continue while the current integer is greater than 0. Is that what you expected? 4 is the sum of 3 plus 3 plus minus 2. But if we wanted the loop to terminate when a negative integer is received, then we didn't print the correct value. The issue is that we need to stop the loop before the integer is added to the sum. So we could restructure the code. By initializing curInt to 0, it's safe to add it to the sum, and then we can do the addition at the beginning of the loop. That way, we check the condition immediately after the integer is received. If it's 0 or negative, we stop. And if it's positive, then we add it to the sum at the top of the next iteration of the loop. This works fine, but I don't like that code. It's got a trick in it, and that makes it hard to understand. We have to see that the task for a single iteration of the loop, accepting a number and adding it to the sum, is split over 2 iterations. This is one place where you might consider using break. Here's why we use it. The code that is created will be easier to read. Let's go back to our original program. The keyword break terminates the loop iteration. So if this break is executed, then we will exit the loop. We guard the break statement with a conditional. If we want to stop, if the current integer is 0 or negative, then we execute the break to end the loop. I kind of like this because it's natural. We like to think about stopping conditions. And here's an important point. I replace the loop condition with a strange value. 1 always evaluates to true, and anyone who sees it will know that this loop is infinite. It will never terminate by itself. This is a flag. It tells the reader that something interesting is happening inside the loop, and it's an important part of using break. If you don't flag to the user that you're using break, then they may not see it, and the code will be harder to understand. And again, our code works. So we have 2 working versions. They're functional. Now we need to ask which one is better. Good programmers can honestly disagree about this example, but my opinion is that the version with break is easier to understand because it keeps the job for 1 iteration of the loop within a single iteration, rather than splitting it across 2 iterations. Let's take a look at a different example. This code uses a nested loop to print a square of asterisks. What if I wanted to not print asterisks on the diagonal? We need to add a condition. In this case, the clean thing to do is to use if-else. Print a space if the row and column numbers are the same, print an asterisk otherwise. As you can see, this runs fine. But here's another option, continue. Continue, if executed, causes the rest of the loop body to be skipped. The loop continues execution by performing its update, checking the condition, and possibly executing the next iteration of the loop. But that means, in this case, that if I and j have the same value, then the printf statement is skipped. This solution also works. So which one is better? Again, 2 good developers can disagree on this question, but in this case, I would not use the continue statement. First, it makes the code harder to read. There's no flag, so if I look at the for loop, I think every iteration is going to be executed. Second, The code is not significantly shorter or cleaner. It's about the same length and complexity. We can use continue here, but there's no compelling reason to do so. Many developers don't like using break or continue. However, they are useful commands if used in moderation and for the correct reasons. Never use these statements just because you can, or because it feels like a shortcut. That can and often does lead to very difficult to read code. Instead, compare the code that results with a break or continue to the code you write if you didn't use those statements and determine which code is better.